All right, so my name is Ian Douglas. I'm a senior developer advocate here at Postman, and I'm here just to sort of host and help moderate a little bit. But with me today, I've got Yash and I've got Harshit. They're both security engineers here at Postman. I'm going to give them a few moments to introduce themselves, talk about their background a little bit. So let's start with Yash. Yash, why don't you tell us a bit about yourself?
Sure. Hey everyone, I am Yash. So basically, I am working at Postman as a senior security engineer, and we are part of application security team here at Postman. Over to you, Harshit.
Hey everyone, my name is Harshit, and yeah, I'm the part of the application security team. Here we automate a lot of vulnerabilities using Postman itself.
How did both of you get into a security background? Like, did you start as software engineers and then get interested in security? How did that sort of transpire? Let's start with Yash again.
Basically, I started as a security engineer itself, but that's a long story. So I was during early school years, my Facebook account got hacked. And after that, I was introduced to the world of security and how to maintain security practices.
That's great.
Yeah, it's for me, security was in my bachelor's of engineering, and earlier I was into competitive programming. There I learned a lot of stuff, and I was like, okay, what next? And security was my calling there, I feel like, and yeah, it's been amazing since then.
That's great. Fantastic. Well, we really appreciate both of you taking time today to kind of share your expertise around security. So, but before we get into the actual topic, we actually want to learn a little bit about everybody that's attending today. We got well over 100 people attending so far. We got more people kind of trickling in. We're going to go ahead and we're going to launch a poll really quick just to learn a little bit about you. So let me get that launched, and then I'm going to walk through a couple of slides just to kind of explain what these questions are. So if you can take a few moments to fill out this poll for us, that would be fantastic. The first question is going to be, how long have you been using Postman? If you're new to Postman, or if you've only been using it a short amount of time, or if you've been using it a really, really long amount of time, we'd love to hear your experience level with Postman. The second question on the poll is, how long have you been using or building APIs? And we'd love to hear a little bit about your experience actually consuming APIs or building out APIs, if you have any experience in that area at all. And the third question is going to be how long you've been working in some sort of security role or have some sort of interest in security when it comes to APIs, if you have any background in that. These questions will help us to kind of look at the kinds of content that we present in these monthly webinars for Intergalactic. And we'd love to kind of hear a little bit more about your collective background. That'll help us kind of understand, do we need more beginner level content? Do we need more advanced level content based on everyone's background? So we really appreciate you taking a moment to do this. We're going to give just a few more moments for folks to answer these questions, and then we're going to close off the poll here. So it looks like we had about 15% of you are brand new to Postman, about 20% have less than 6 months experience in Postman, 12% 6 months to a year, 30% 1 year to 3 years, 24% of you have been using Postman for 3 years or longer, which is fantastic. For those with API background, it's pretty split. We've got 16% who've never built or used an API, 14% less than 6 months, 16% 6 months to 1 year. So again, very entry level here, which is fantastic. About 30% have been doing work with APIs for a year to 3 years, 25% 3 years or more. And then for the security role, 74% of you have not been in a security role. And for the other percentages, less than 6 months, we had 7%. 6 months to a year, we had 4%, 1 year to 3 years, 5%, 3 years or more at 9%. So we really appreciate everybody filling that out for us. Again, we're going to have a feedback survey at the end of the session for everyone to fill out as well, if you want to share some extra thoughts. So thank you for filling that out. All right, well, let's talk about the agenda. So as a reminder, we are recording the session today. And we're going to publish the video on YouTube afterwards. If you're watching this on YouTube, all the links are down below for all the links that we're going to be sharing throughout the webinar. We're going to be introducing the idea of API security and why it's important. We're going to give you a bit of background on an organization called OWASP. who also works to educate people about security needs in both web development and API development. We're going to look at 4 of these OWASP vulnerabilities that they publish on a regular basis and examine how they work to exploit these using a known vulnerable version of GraphQL. So we're going to be sharing a link to a version of GraphQL that is known to be vulnerable on purpose, so that you can go in and you can do some security testing as well. So you're welcome to follow along as we demonstrate some of the work. The moderation team are going to be dropping lots and lots of links in chat as we go. So if you feel a little bit lost, like you can't keep up, that's okay. You can always come back and watch the recording and work at your own pace. So like most security training, it is important for us to kind of share that this information is for training and education purposes only. Please don't use this knowledge for accessing systems that you're not explicitly permitted to do any sort of vulnerability testing. This is meant to be educational and to teach you a little bit about API security and to demonstrate that within Postman. So please use this information responsibly. And so what I'm going to do from here is I'm going to hand it over to Harshit. Harshit's going to take over the screen share, and he's going to get us started on the background of API security.
Thanks, Ian. Hopefully my screen is visible.
Mm-hmm.
Yep. So over the years, we have seen a drastic increase in the API adoption. And because of the increase, security is the most important factor when it comes to interacting with an API. API security is a practice of preventing and mitigating attacks that originate at the API level. And hence, it is a very crucial pillar of any organization's overall security strategy. If we're talking about API security risks and not talking about the OWASP list, it would be a crime. So let's move on to the OWASP Top 10 API security risks for 2023. So before going into the list, I want to talk about what is OWASP. For those who are not familiar, OWASP stands for Open Web Application Security Project. They are an open source community where anyone can join and contribute. They started with web application security and published their top 10 list of vulnerabilities attacking web applications in, I think, 2003, and then 2004, and then every few years from now. In 2019, they first published their top 10 API security risks. So yeah, let's see. The above OWASP Top 10 API 2023 list is an amalgamation of community voted risks plus the recommendations of the members. It basically highlights the biggest and most impactful API security issues in the internet today. Let's dive in the updates in the new 2023 list. So the first key OWASP update is broken object property level authorization. If we see from the previous slide, the first, third, and fifth, they are basically authorization issues. So authorization still remains the biggest security threat amongst others. Then you must be thinking that, okay, why can't people developing software take care of these issues at an architectural level? The reason is it is not possible because it is implemented on a use case basis. From the earlier list, excessive data exposure and mass assignment are now part of this category, which is called BOPLA. This category essentially outlines how attackers can exploit endpoints by accessing or modifying object properties without authorization. The source issue, like the reason this issue occurs when an application is that when an application validates the user's access to the functions and the objects, but fail at validating the access to specific properties within an object. Let's take a look at an example. So here there are, let's say you have an e-commerce portal where you can have your business partners sign up to become affiliated with your store. At the most abstract layer, that is the function level, we need to ensure that the API to sign up new affiliate partners can only be used by store owners and not the potential affiliate themselves. Otherwise, a fake partner will be able to register themselves as your affiliate partner. Wow. Second, just one layer deeper, we'll get into the object. At the object level, we should be able to validate that the store owner cannot change the partner ID and sign up another party. So if you send a request to accept a partner, let's say A, you being the store owner, you should not be able to register another partner B in the same request. Although you can send another request, but in the same request, that should not be possible. And finally, we are at the object property level, which is the lowest level where one can exploit an authorization issue. So here, we should be able to validate that a partner cannot change the inventory of your store. So let's say you register a partner and they should not be able to change the inventory data in your store. Although they will have the access to the object inventory because you have given them some sort of access, but they should not gain access to the inventory count ID property of the object, as it can be only be updated by you. Second update for today is server-side request forgery. Server-side request forgery happens when a system accepts a URL from an external source, in this case an API, and then makes decisions or saves this URL without properly validating that input. The URL then sends a malicious request to someone it's not supposed to go, which can result in all sorts of chaos behind your perimeters firewall, such as enumerating your service systems and performing actions against the internal systems, and hence exposing sensitive data. When an API is vulnerable to SSRF, it tricks the apps into sending requests on attacker's behalf with all of the same authority that the application's service account is granted to your network. A very common SSRF attack is to force the API to gather data from a different place than the API would normally access and bring the sensitive data back to the attacker. The third update for the day: unrestricted access to sensitive business flows. So sometimes there is no actual vulnerability. Think about a very interesting use case. Find some airline that sells tickets with no cancellation fee. Just go and purchase most of the airplane seats, and then 2 or 3 days before the flight, cancel all the tickets. This will actually force the airline to lower the ticket prices because they want to fill the airplane. And once they do, just buy a new ticket at a much lower price. This shows that there was no actual issue in the API at all. The only time you can see the problem is when you zoom out from the API, look at the whole chain of requests in the context of business flows. Moving on to the last update for the day is unsafe consumption of APIs. Often programmers trust the values they receive from APIs. This is because APIs are owned and operating by third-party system. For example, you implement Google's authentication in your login system. So you as a developer would think, okay, I trust Google, Microsoft, because they are such a huge company, they must have amazing security. But unfortunately, all humans make mistakes sometimes. And the security of the software is almost never guaranteed. So let's say it's very possible that an API from Google, Microsoft, or any other well-respected company could have been compromised or being replaced by a malicious API, or just sends back a data that is very vulnerable, which makes your system vulnerable. So validating that data from the API is not just a statement, it's a prudent web security. Now, we talked a lot about the OWASP Top 10 2023 list. Let's dive into a new and upcoming technology in this space, GraphQL. Some of you may be experts, but for the others, let me walk you through what is GraphQL. In a sense, GraphQL is a query language and a server-side runtime. It was developed by Facebook to optimize RESTful API calls in 2012. It's basically a language for querying data. Unlike other query languages such as SQL, you don't use GraphQL to query a particular type of data store such as MySQL. Instead, you use GraphQL to query data from any number of different sources. The structured way in which we make requests present two types of operations: queries and mutations. Queries are similar to GET calls, just like in REST. And whereas mutations are very similar to post calls, they update the data. I mentioned server-side runtime. So the runtime part points to the fact that a GraphQL API runs on a server and not on the client side. In the GraphQL API, we shape our data with a strictly typed schema, telling it how to resolve the data when asked for. Where the data comes from, it does not matter. It could be from a database, microservice, or even an underlying RESTful API. You may ask, how does it work? So on the server, we create a GraphQL schema based on the data we need to build on top of our app. Let's say we're building a job board. So here we model out the job, company, and location types in our GraphQL schema. For each data source, what we have to do is we have to write resolver functions or business logic functions, which take this model and the query and connect to the data in our graph. Perhaps in our example, the job data could come from an external API, and maybe we get the location from Google Maps API. And third, finally, write your query, specifying precisely what you like to fetch. No more, no less. That's how easy it is, or just sounds like it. So now let's talk about why it was developed in the first place. It was basically designed to be more efficient, performant, and provide a better developing experience for working with data in a client-server architecture. There are a lot of details here, but keeping in mind the time that I'm allowed to bore you folks, I will move on to the last theoretical topic of the presentation. So common GraphQL attack vectors. First is introspection. First and foremost, when encountering a GraphQL endpoint, you should be doing introspection. What do I mean by introspection? Introspection here, as you can see, this API graphql.postmanecho.com/GraphQL, the left side here, the query explorer part, that is basically your GraphQL schema. So if introspection is enabled, what your GraphQL schema does is sends all the available data types in the GraphQL schema to the client itself. This allows basically anyone with the access to the API to see the layout of the entire database for us. And if luckily, Postman does this for us. Yash will be presenting it later. Second, information disclosure. Even if introspection is disabled by the developers, GraphQL has the advantage from the attacker's perspective to be incredibly verbose in its error messages. One can blindly start to create any invalid query and slowly build into a valid query just by reading the error messages. Third is missing access control. By default, GraphQL instances do not implement access control at all. It is left to the developers to implement proper access control in the code of the application, either between the HTTP server and the GraphQL server. So you can imagine the misconfigurations that can happen, or a developer can simply just forget to implement these access control altogether. Fourth, bypassing rate limit. Because of the nature of GraphQL, we can send multiple queries in a single request just by batching them together. If the developers did not implement any kind of mechanism to prevent us from sending batch requests, then we could potentially bypass rate limiting by sending multiple queries in just single request. As there is only one request sent from the client to the GraphQL instance, classic rate limiting such as from a WAF does not apply here. Let's take an example. You are trying to brute force a 2FA, an OTP or any 2FA system. What could happen if it is implemented in GraphQL? An attacker can send all the possible combinations of the 2FA or the OTP in one request, and the server will respond to with a valid refresh token. Last but not the least, but one of the most important of them is denial of service. Since GraphQL could be the single entry point in the system, it could also be the single point of failure. So because limiting query depth is disabled by default, nested queries can be performed in order to cause denial of service attack. Because of the nature of the GraphQL language, multiple queries can be nested by creating a cascading effect on the request, and your database could crash, your applications could crash. Yep, that's all from my side. Now, yeah, let's explore some exploitation scenarios. Yash, over to you.
All right, let's explore how we can find and exploit the vulnerabilities explained earlier by Arshit. So today, like for demo purposes, we will be using DVGA, Damn Vulnerable GraphQL Application, as a playground. And just as a note, DVGA is an deliberately weak and insecure implementation of GraphQL, which is only meant to learn and practice security. So please don't deploy it on production, and don't expect that all of these vulnerabilities that we try here will work as it is on your production servers. Now, DBGA has this multiple operation modes called beginner and expert level. So today we will be only focusing on the beginner level mode, and expert level contains a few security controls that you will need to bypass. Let's try. I have already configured the DBGA on my local system in the interest of time. So we will directly deep dive into hunting the vulnerabilities. Let's verify if the DBGA is actually loading on my system or not. Yep, it is. So this is the welcome page for DBGA. And there are also some of the GraphQL resources that you can explore. Now, generally, the first step in the journey of exploiting a GraphQL API is to find out if the GraphQL endpoint supports the to find out the GraphQL endpoint. And generally, the GraphQL endpoint is /GraphQL. Obviously, right? It will be /GraphQL. But if you are not able to find out, you can always intercept the traffic from front end to identify the exact endpoint that your app is using. So here, for DBGA, the GraphQL endpoint is /GraphQL. And another interesting case here is this endpoint supports both GET and POST request. Now, as we have already found out the endpoint, let's move on to Postman and see how we can exploit this further. So first, we will try performing an introspection and verify if the introspection is enabled or not. So by default, Postman has this feature which will automatically try introspecting your schema. And if the introspection is enabled, it will completely retrieve your API schema and show you to it. So as you can see, we have multiple query objects, mutations, and a subscription. But let's also try to understand how we can manually fetch this schema. So this is a generic query that will help us retrieve a basic schema and only verify if the introspection is enabled or not. Here, the underscore schema is a root field, and we are trying to query the subfields like query type, etc. So as you can see, the introspection is enabled here. So now we will make use of a tool called GraphQL Voyager. So GraphQL Voyager is basically an open source tool which will help us visualize our GraphQL schema. So let's open it, change schema. We will copy the detailed introspection query that they give and replace here. We will let it run. So as you can see, this is a kind of a pretty complex introspection query containing multiple fragments because it is supposed to retrieve the complete GraphQL API schema from your server. Now that we have the introspection result, we will copy it and paste it back to the GraphQL Voyager window. So this is how the GraphQL schema of Damn Vulnerable GraphQL application looks like. We have multiple queries and we have three primary objects: paste object, user, and owner. We also have something called audit object, which is basically meant for audit logging purposes. And it will try to identify if you perform any of the malicious queries. An interesting case to note here is we have this two paste and owner objects which are interdependent. So they have a circular dependency. You can traverse from paste and owner and vice versa. All right. So remember that schema can be a useful source of information, as sometimes it will also contain the deprecated resources like mutations or queries, which are generally not used in front end or in the system. So such older queries or mutations can be a goldmine for an attacker because they will be mostly vulnerable to authorization attacks. Now, it is always recommended to turn off the introspection in production servers, and some of the GraphQL engines also do this by default, but that's just a preliminary measure. Now, what if as an attacker, you want to exploit it further? So as Ashit explained earlier, we can utilize something called field suggestion. So here, generally GraphQL engines, if you try querying an incorrect query, they will use edit distance algorithm to find out the correct queries that your GraphQL application supports. So here, as you can see, we have received cannot query field system because that is not a valid query here. We don't have a system as a valid query. And it will suggest us some of the valid queries that we can try instead. So as an attacker, you can try performing a brute force here. And you can also use open source tools like Clairvoyance, which will help you automate the task for you. So basically, Clairvoyance will perform a brute force for you and automatically retrieve and give you the GraphQL API schema, even if the introspection is disabled. Okay, so moving on to the next class of attacks, let's see what all other scenarios that we have. So we have already covered the basis for reconnaissance. Now we will move on to the next class of attacks, denial of service. Okay, so first we will start with the resource intensive query attacks. So here we will basically try finding a GraphQL query which will consume most resources and takes longer to respond. So as you can see, we have multiple system-related queries here, and generally system-related queries will take much longer to respond and consume more resources because they are busy performing OS level operations rather than the database operation. So we will first try with the system update query and determine what the response time is. According to my system configuration and like previous runs, it should take around 40 to 50 seconds. But let's say how an attacker can abuse this. So an attacker can abuse such resource intensive queries by sending multiple requests or combining them with the other methods that we will explore later. So as you can see, it took around 25 seconds this time. Now let's move on to batch query attack. So batch query attack is nothing but just a way to combine multiple queries into ones. So what you will do is we will bunch a group of queries into an array and send it across. And here, the query that we identified in the last attack, resource intensive, will be very helpful. So we have bunched the resource intensive query that we identified, system update, as a batch of two, and we will send it to our server. So now we have only tried querying the two queries, batching the two queries here because we want to verify if the batching is enabled or not. It will take a considerable amount of time. So in general, like in GraphQL, batch requests are handled sequentially, which makes it pretty vulnerable to denial of service attacks. And for some of the GraphQL engines, batching is disabled by default as well. Now, till it loads, let's go back to our DVGA front end and explore what are other functionalities that we have. So this DVGA is basically a similar, or you can say clone of Pastewing, which allows us to create nodes, public and private nodes. It looks like my denial of service attack worked. Okay, so DOS worked. So I will go ahead and restart my server. Yeah. All right, so it took around 1 minute to load this. Now let's explore other class of denial of service attacks. So other attack vectors include deep recursion, field duplication, circular fragment, and the alias-based attack. Now we will get a bit more crafty and work some magic with recursion. So we will basically use the interdependent object that we have seen earlier, the paste object and owner object, and try crafting a recursive query, which could lead to denial of service. So we already have this interdependent query here, which goes to around 8 levels deep. And we will try querying it and let it go. So by default, GraphQL will not restrict the length of queries. And these GraphQL queries can be nested one inside the other to create the cascading request to the database. As a result, we can use the nested queries to perform the denial of service attack.
Yash, while we're waiting for that to finish, I have a quick question. Is there ever a good use for a recursive query in GraphQL? Or is this something that would be very uncommon in GraphQL?
There is, but generally it is uncommon. But there could be some use cases where, let's say, you want to fetch a recursive query from multiple use cases, or you want to go one level deep and add a one more filter for the other resources that you have.
Cool,
Well,
thank
it
you.
looks like my server crashed again. I will go ahead and restart it. So this is the thing with denial of service attacks. So please don't try it on your production server. Never. I have restarted it. It should be back up in a second. Yeah, server is back up. All right. So let's move on to the other class of attacks, field duplication. So field duplication, as the name suggests, basic idea here is to just duplicate the field. So by default, GraphQL won't blink an eye at resolving any field you throw at it, even if it's duplicated. So as you can see, within the paste object and owner and level div, so we are basically using the same recursive query from the past and try doing a field duplication attack here. So we have multiple fields supported by the paste object, title, content, public. We will select a few of them. And we have also duplicated the IP addresses field 5 times. So let's try querying it and observe the response time. So it took around 326 milliseconds. Now, what if we increase the depth further and increase it to, let's say, 300 times? That could probably crash my server once again. Yes. All right. So as you can see, the response time increased significantly. Now, as an attacker, you can even increase this further or try running it simultaneously to perform a denial of service attack on production. All right, so let's move on to the aliases based attack. So aliases is nothing but you will give a new name to your query. So here, as you can see, we have given the our good old system update query 3 new names, Q1, Q2, and Q3. Let's try running it as well. So basically, whenever a batching is disabled on the production or any GraphQL servers, you can use the alias-based method to bypass as a bypass in those scenarios. And multiple aliases can also be combined in a single query and sent to the GraphQL server. So if there's no proper remediation in place, it will ultimately result in a denial of service situation. Okay, it loads. Let's see if we can explore this further. So there is a one more thing called this GraphQL attack matrix. Till that loads, we can look into this. So basically, this is an attack matrix for all the common GraphQL engines, and it will show you what kind of default security controls are enabled on your GraphQL engine or not, which will help you determine whether you want to implement a custom security setting or you can go by the defaults only. So bad. No, our server crashed again. Bad. I have restarted. Yeah, well, online. All right. So moving on to the last class of denial of service attacks and our last attempt at restarting the server, circular fragments. So circular fragments are nothing but a class of fragments which will cross-reference each other. So as you can see here, we have created a fragment A on paste object, which tries fetching the subfields content and title from paste. And we have created a fragment B as well, which is basically the same content and title subfields. But both fragment A and fragment B are cross-referencing each other. And as part of query, we will only reference the fragment A. So now what will happen here is an attacker could exploit this to perform a denial of service by simply cross-referencing two fragments with each other. And it will create a never-ending loop. And this could be also used as a bypass scenario if, let's say, batching or deep recursion or the field length limits are implemented. Because within the query, you are just implementing a single fragment. All right, so enough talking about how to exploit these things. Let's see how we can prevent this. I will now open our GraphQL prevention cheat sheet by OS, and we can look into some of the DOS prevention scenarios. So like as Harshit recommended earlier, you can add depth limiting to incoming queries or amount limiting. For both of this, you can find any ready-made libraries from the open source package managers. And this will help basically protect against the deep recursion query that we have seen. Now, you can also add a pagination to limit the amount of data that can be returned in a single response, or add a reasonable timeouts at the application layer, infrastructure layer, or both. We can also consider implementing query post analysis and enforcing a maximum around query post query. But do note that implementing a query post analysis is a bit tricky. And if you don't consider all the aspects, you could block a genuine user query. And like always enforce rate limiting on incoming request for IP. So basically this applies for all the API endpoints irrespective of GraphQL or REST technologies. And you can also use the batching and caching technique on the server side. So basically what happens is whenever you try fetching the data from GraphQL, it will make a database call. So it will increase the load on your database. But if batching and caching is enabled, it will batch the request before sending it to your database, thus reducing the load on your servers. All right, enough of DOS attacks. I guess everyone is bored now with DOS. Let's move on to SSRFs. So if we go back to our damn vulnerable app, here's an interesting option called import paste. So basically this import paste option allows us to import or create a new paste from any random URL. So let's try the postman-info.com/cat and see what happens. So paste was imported successfully. We can go to public pastes. So as you can see, it basically retrieved the data from postman-info.com and created a new page from that URL. Now let's see if our developer has implemented any security controls here or not. So we have this mutation which powered that functionality of importing page. It accepts host, port, path, and scheme parameters. Now I will try calling a random port on my localhost which doesn't exist. Let's say 37303. So there's nothing running on this port on my localhost, but still like we will use it to identify the error response, which could help us further craft an attack. So as you can see, the result, it is an empty result. So basically the developer has implemented an input validation or the response validation, we can say. Now I have another interesting service running on my local host. Basically, it is called capture the flag service. So let's see if we can try calling that service and find the flag. So I will change the URL to push.docker.internal because this DVG is running on Docker, whereas my capture the flag service is running on the local host. And path will be flag.txt. tada, we were able to retrieve the flag. So you might think that this SSRF is very simple and it's look trivial, but SSRFs can pose a significant risk in a cloud environment. So basically an attacker can fetch your instance metadata via SSRF, which might contain sensitive information and other environment variables. Such vulnerabilities can also be leveraged to perform reconnaissance or enumeration of your internal environment, which attackers generally don't have access to. So you can say SSRF is similar to giving a third party your backdoor key. So that third party can enter your backdoor, enter your house, and they can roam around your house, poke around the things, and if that safe is unlocked, they can also collect your valuables. So it is a similar situation here. Let's say if within your network boundary, if there's any unauthenticated endpoint, that attacker can exploit that using this SSRF, which even might not be present in the same system. All right, so that's it for the manual attacks. Let's quickly move on to see how we can automate this security test to ensure that our production is constantly compliant. So first, we will explore automating this introspection query. So we have this basic schema query that we had written earlier. Let's try calling it once to verify. All right. So as you can see, the schema query written. So here we will basically try writing two negative test cases based on this schema parameter and the response code. So here we are basically checking if the response body contains the underscore schema. It should not exist if the introspection is disabled. And we will also check if the response status code is 403 forbidden, which is not the case here. So test will fail. Now, next we will add a test case for field suggestion. So here we will try querying an incorrect field. And we will basically build out a test case based on the did you mean and the cannot query field strings. So we have basically listening for the cannot query field system and did you mean error message. And if it is not successful, the test will pass. Now there was another interesting SQL injection scenario where the paste object supported the filter, and that filter was basically allowing any arbitrary string without input validation. So we have already identified an exploit for this, which will basically help us retrieve the SQLite schema on databases. So this will help us retrieve the create table audits and complete the schema queries that we have. So again, we will create a negative test case here to verify that the response should not contain the create table audits body in any of the bodies. So you can consider this as a kind of a regression test. Now let's try running this collection and see how we can automate this. We will uncheck this password brute force first and run automating GraphQL security tools. So as you can see, all of those test cases failed. Now you can also automate this run using the scheduled run or Postman CLI, or you can even integrate this with your CI/CD pipelines. Now let's see how we can use the password brute force, how we can perform the password brute force using Postman. So as we explored earlier, there were multiple system queries, and one of that was system diagnostics, which required username, password of admin, and if we are successful to exploit that, it will allow us to gain this cell on system. So we will basically assume that the username is admin here and password is a payload variable. Command that we will try is ID. And here we have written a test to ensure that the response doesn't match this command. Now let's run our collection run again and check all other things. And we will select a file called payload.json. So payload.json is nothing but a combination of vulnerable, or you can say generic passwords that we have found from internet that we will be using for brute force. So as you can see, there are 17 iterations because we have added 17 passwords. Let's try running it. Yep, 16 test cases failed, passed, and one failed. So we basically found our password of admin, and it is changed me. Now let's go back to the query and try exploiting it. Yep. We were successfully able to exploit this, and now we have shell on the system. Like we can run any arbitrary commands here. So that's it for the automation. Now I will hand it over to Ian. Okay.
Awesome. Thank you so much, Yash and Harshit. Cool. Well, we're going to talk a little bit about some additional resources that you can look at. We're going to drop these links in chat for everyone as well. So the first resource that we'd like to share, again, is the OWASP Top 10 for APIs that was published in 2023. This was just very recently published. It was kind of in a request for comments status for a long time, but they've just published it for 2023. We've also got more Intergalactic Sessions. We do run these webinars every month, and they're free to register. We give you a copy of the recording afterwards. We also publish these on YouTube. So you can go check out youtube.com/postman if you want to go see any of our previous webinars. Totally free to go check out. We've also got a really fantastic community forum as well. If you've got other questions, if you want to just engage in a lot of conversation with other people who use Postman around topics like security, we do encourage you to go check out our community forum as well. And then we've got the link for YouTube at the bottom here as well, if you'd like to see that. Cool. We're going to have the moderator team drop this link in chat as well. This is a feedback form that we'd love everyone to fill out. So we're not quite done yet, so don't take off, because we do have some questions that we want Yash and Harshit to answer as well. But if you could take a few moments to load this up in your browser and submit this feedback for us, we'd really appreciate it. It really does help inform how we do these webinars in the future, what kind of content you'd like to hear, what you thought about this particular session, but also just, what kinds of topics would you like? Would you like more beginner level, intermediate level, advanced level, and around what kinds of topics? Do you want us to do more about security? Do you want more about testing? Do you want more about building out a particular type of API? Things like that. So we'd love to hear everybody's feedback from that. The last slide here, we're going to copy this URL onto this slide as well. But we've also got the Twitter URL and LinkedIn handle for Yash and Harshit if you'd like to keep in contact with them. We're going to drop these links for them as well. If you'd like to stay in contact with them on social networking, they've agreed to have these shared out. So if you'd like to connect with them, please do so. Thank them for their time and let them know what you thought as well. We do have a handful of questions that we'd like to kind of hear from Yash and Harshit. So I'm going to start here. We had a question from Swaraj asking, can you tell us the difference between web penetration testing and API penetration testing? As far as like dealing with APIs and like how are they different when we're talking about APIs? So Harshit, why don't you take that one?
Yep. So as mentioned in an example for booking flights and then canceling and rebooking at a lower price, it's just the same. When you look at a web application, APIs are involved. So essentially, when you test a web application, you have to test for APIs. But whereas if you test for APIs, a lot of test cases for web applications would not be covered in the API level. For example, just a static API would not help you get XSS. Or if there are multiple APIs involved in a flow, then that would be considered in web application pen testing rather than in an API pen test.
Great, and I'm just dropping a link in or a comment in chat. XSS is what we call cross-site scripting. It tends to be, JavaScript vulnerabilities and so on. Cool. All right. I actually had a question as well. So Yash, you mentioned that you would typically turn off server introspection in a production system, specifically with GraphQL. How long, so you showed us that GraphQL Voyager tool. How long would that take to actually sort of brute force finding all the different tables and schemas and things like that? Does it take like a couple of moments? Does it take several minutes? Could it take like a really long time? Is that something that a security team could see happening? That somebody's trying to sort of brute force that and maybe block it from happening?
Yep. So like that tool was Clairvoyance, which will help us brute force the API schemas. And it generally takes few minutes, but it will really depend on the complexity of GraphQL schema that your application has. And
Okay.
a security team can definitely look into what is going on their servers via the network logs and application logs that they have. And it could be easily blocked by our new next-gen firewalls that are nowadays coming.
Okay, super. We also had a question come in from an anonymous guest on Zoom. If the API passes authentication for the bearer token, how would you bypass that token and make the API call anyway? Or I guess during that part of the demonstration, were you only looking at areas of the application which were open without needing a bearer token? Harshit, do you have? Yeah, okay.
Yep. So the DVGA is essentially vulnerable, and there is no authentication in terms of the whole API at all, although there is an admin access there. But in this case, the question you're talking about is the bearer token authentication would not be implemented on the GraphQL gateway, but whereas it would reside in the logic and the RESTful APIs that are behind this GraphQL. So at the GraphQL layer, no, there is no authentication present. But if you try to query some specific data with some specific value, there could be.
And would that also apply to other kinds of APIs, not just GraphQL,
Yes.
like REST APIs and so on? It would still apply. Okay.
Yep.
Cool. And then last question we had from Set. Maybe Yash, maybe you can take this. Is it a good idea to run the OWASP tests on a CI/CD pipeline, or should you only run that periodically? What would your recommendation be?
It is definitely a good idea to run it as part of your CI/CD pipeline, because like it will basically help you catch the vulnerabilities early in the life cycle. But do ensure that like you modify those test cases according to your environment, and don't overwhelm your developers with the false positives or vulnerabilities that are not impactful.
And OWASP does make a lot of open source tools available for developers and DevOps teams and so on, like Zap and so on, to help with these application testing suites and so on, to help with these kinds of things. And whether you put that in a CI/CD pipeline, like Yash said, is really up to you and your organization for how you want to check that as you go. Awesome. Well, that was it for our questions. Really appreciate all of your time. Yash and Harshit, thank you so much for sharing your knowledge and walking us through this content today. Again, if everyone could please take a moment and fill out that feedback survey for us, we'd really appreciate it. We'll get this posted up on YouTube, usually within the next week, but you'll get an email right away from Zoom with a recording when the session is finished processing on their side. You'll get an email when it's ready to kind of come back and watch yourself. Thank you to everyone who attended today. We had a really good sort of peak attendance. We really appreciate everybody's time, and we're looking forward to seeing that feedback. We do have another Intergalactic coming up in a couple of weeks where we're unboxing everything that Postman kind of published in the last quarter. So definitely go register for that. It's free. You can come hang out with the team and ask lots of questions about the kinds of things that were in the release. So we'll catch you on that Intergalactic. Have a great day. Have a great evening, time zone, wherever you are. Thanks again, Yash and Harshit. I know it's really late where you are. We really appreciate your time today. And we'll see everybody in the next Intergalactic session. Cheers.